Aligning items in a Flex container. One of the reasons that Flexbox quickly caught the interest of web developers is that it brought proper alignment capabilities to the web for the first time. It enabled proper vertical alignment, so we can at last easily center a box. In this guide, we will take a thorough look at how the alignment and justification properties work in Flexbox. To center our box, we'll use the Align Items property to align our items on the cross-axis, which in this case is the block axis running vertically. We will use justify content to align the item on the main axis, which in this case is the inline axis running horizontally. Main axis, cross axis. Also major and minor, if you like those terms. You can take a look at the code of this example below, change the size of the container or nested element, and the nested element always remains centered. So is this interactive? I'm not sure. No, I wouldn't expect that to be, because there's not much code. Okay, so we have the box class, display flex, align item center, justify content center, box class, child div, width 100 pix, height 100 pix. We have div class equals box, and then we have a empty div inside of that, and then we close off the layout. Properties that control alignment. The properties we will look at in this guide are as follows. Justify content controls alignment of all items on the main axis. Align items controls alignment of all items on the cross-axis. Align self controls alignment of an individual flex item on the cross-axis. Align content described in the spec as for packing flex lines, controls space between flex lines on the cross-axis. We will also discover how auto margins can be used for alignment in Flexbox. Note, the alignment properties in Flexbox have been placed into their own specifications. See SSXbox Alignment Level 3. It is expected that this spec will ultimately supersede the properties as defined in Flexbox Level 1. The cross-axis. The align items and align self properties control alignment of our flex items on the cross-axis, down the columns if flex direction is row, and along the row if flex direction is column. We are making use of cross-axis alignment in the most simple flex example. We will add display flex to a container. The child items all become flex items arranged in a row. They will all stretch to be as tall as the tallest item, as that item is defining the height of the items on the cross-axis. If your flex container has a height set, then the items will stretch to that height, regardless of how much content is in the item. Okay, so we have, So we have the items 1, 2, and 3, and then when we change the height to 200 pixels, 1, 2, and 3 still going to the top and bottoms of the container. The reasons the items have become the same height is that the initial value of align items, the property that controls alignment on the cross-axis, is set to stretch. We can use other values to control how the items align. Align items flex start, align items flex end, align items center, align items stretch, and align items baseline. In the live example below, the values of align items is stretch. Try the other values and see how all of the items align against each other in the flex container. Okay, so we have an example here. We got multiple scroll bars going on here. Box, display flex, align items stretch. Div class equals box. We have divs 1, 2, and 3 has extra text. And if we look at what that looks like, so all of them have stretch to accommodate the third box. Aligning one item with align self. The align items property sets the align self property on all the flex items as a group. This means you can explicitly declare the align self property to target a single item. The align self property accepts all of the same values as align items plus a value of auto, which will reset the value to that which is defined on the flex container. In this next live example, the flex container has align items flex start, which means the items are all aligned to the start of the cross axis. I have targeted the first item using first child selector and set that item to align self stretch. Another item has been selected using its class of selected and given an align self center. You can change the value of align items or change the values of align self on the individual items to see how this works. Okay, so we got 1, 2, 3, and 4. Then we have dot box, display flex, align items flex start, height 200 pixels. Dot box, I'm not sure how that works. First child, align self stretch, dot box, dot selected, align self center. Div class box, div 1, 2, okay, class selected 3, and then 4, okay. Changing the main axis. So far, we have looked at the behavior when our flex direction is row, and while working in a language written top to bottom. This means that the main axis runs along the row horizontally, and our cross-axis alignment moves the items up and down. So we got main axis, flex direction row, cross-axis, flex direction row. If we change the flex direction to column, align items and align self will align the items to the left and right. Right? Cross-axis, flex direction column. Main axis, flex direction column. You can try this out in the example below, which has a flex container with flex direction column, yet otherwise is exactly the same as the previous example. Okay, 1, 2, and 3, and 4. Dot box, display flex, flex direction column, align item start with 200 pixels. Dot box and some type of selector for first child, align self stretch, dot box, dot selected, align self center. Div class box 1, 2, and 3 is selected, and 4. Aligning content on the cross axis. The align content property. So far, we have been aligning the items or an individual item inside the area defined by the flex container. If you have a wrapped multiple line flex container, then you might also want to use the align content property to control the distribution of space between the rows. In the specification, this is described as packing flex lines. For align content to work, you need more height in your flex container than is required to display these items. It then works on all items as a set and dictates what happens with that free space and the alignment of the entire set of items within. The align content property takes the following values: align content flex start, align content flex end, align content center, align content space between, align content space around, align content stretch, align content space evenly, not defined in the Flexbox specification. In the live example below, the flex container has a height of 400 pixels, which is more than needed to display our items. The value of align content is space between, which means that the available space is shared out between the flex lines, which are placed flush with the start and end of the container on the cross-axis. Try out the other values to see how the align content property works. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Dot box, display flex, flex wrap, height 400 pixels, align content, space between. Then we have our HTML, div class equals box, and then we have divs 1, 2, 3, 4, 5, 6, 7, and 8 just stacked inside of the main div. Once again, we can switch our flex direction to column in order to see how this property behaves when we are working by column. As before, we need enough space in the cross axis to have some free space after displaying all of the items. Okay, 1, 3, 5, 7, 2, 4, 6, 8. Dot box, display flex, flex wrap wrap, flex direction column, width 500 pixels, height 400 pixels, align content space between. And then we have div class box with divs 1 through 8 just stacked inside of it. Note, the value space evenly is not defined in the Flexbox specification and is a later addition to the box alignment specification. Browser support for this value is not as good as that of the values defined in the Flexbox spec. See the documentation for Justify Content on MDN for more details on all of these values and browser support. Aligning content on the main axis. Now that we have seen how alignment works on the cross axis, we can take a look at the main axis. Here we only have one property available to us, Justify Content. This is because we are only dealing with items as a group on the main axis. With Justify Content, we control what happens with available space, should there be more space than is needed to display the items. In our initial example with display flex, on the container, the items displayed as a row and all line up at the start of the container. This is due to the initial value of Justify Content being flex start. Any available space is placed at the end of the items. Container equals 500 pixels, available equals 200 pixels. The Justify Content property accepts the same values as a line content. Justify Content flex start, Justify Content flex end, Justify Content center, Justify Content space between, Justify Content space around, Justify Content space evenly. Not defined in Flexbox specification. So we have flex start, flex end, center, space between, space around, space evenly. In the example below, the values of Justify Content is space between. The available space after displaying the items is distributed between the items. The left and right item line up flush with the start and end. Okay, 1, 2, 3, 4. Dot box, display flex, Justify Content, space between. Div class equals box with the divs 1, 2, 3, and 4 inside of them. If the main axis is the block direction because flex direction is set to column, then Justify Content will distribute space between items in that dimension as long as there is space in the flex container to distribute. Okay, 1, 2, 3, 4. Dot box, display flex, flex direction column, Justify Content, space between, height 500 pixels. Div class equals box, and then we have 1, 2, 3, and 4. Alignment and writing modes. Remember that with all of these alignment methods, the values of flex start and flex end are writing mode aware. If the value of Justify Content is start and the writing mode is left to right, as in English, the items will line up starting at the left side of the container. Main axis, flex direction row, and then we have start and end. However, if the writing mode is right to left, as in Arabic, the items will line up starting at the right side of the container. So main axis, flex direction row, and then we have start and end. In the live example below has the direction property set to RTL to force right to left flow for our items. You can remove this or change the values of Justify Content to see how Flexbox behaves when the start of the inline direction is on the right. Okay, so 4, 3, 2, 1. Direction, RTL for right to left, display flex, justify content, flex end. And then we have div class box 1, 2, 3, and 4. Alignment and flex direction. The start line will also change if you change the flex direction property, for example using row reverse instead of row. In this next example, I have items laid out with flex direction, row reverse, and justify content, flex end. In a left to right language, the items all line up on the left. Try changing flex direction, row reverse, to flex direction, row. You'll see that the items now move to the right-hand side. 4, 3, 2, 1. Dot box, display flex, flex direction, row reverse, justify content, flex end. Div class box 1, 2, 3, and 4 divs inside of the div class box. While this may all seem a little confusing, the rule to remember is that unless you do something to change it, flex items lay themselves out in the direction that words are laid out in the language of your document along the inline row axis. Flex start will be where the start of a sentence of text would begin. Sorry, let me say that again. While this may all seem a little confusing, the rule to remember is that unless you do something to change it, flex items lay themselves out in the direction that words are laid out in the language of your document along the inline row axis. Flex start will be where the start of a sentence of text would begin. Main axis, flex direction row. Okay, then we got A, B, C, and then end. You can switch them to display in the block direction for the language of your document by selecting flex direction column. Then flex start will be where the top of your first paragraph would start. So then we get start and end, main axis, flex direction column, start and end. If you change the flex direction to one of the reverse values, they will lay themselves out from the end axis and in the reverse order to the way words are written in the language of your document. Flex start will then change to the end of that axis, so to the location where your lines would wrap if working in rows, or at the end of your last paragraph of text in the block direction. Okay, main axis, flex direction, row reverse, and then A, B, C, but it's going in reverse, starting at the right and going to the left. Main axis, flex direction, column reverse. So we got end and start, end on the top, start on the bottom, A, B, C, going up from the bottom to the top. Using auto margins for main axis alignment. We don't have a justify items or justify self property available to us on the main axis, as our items are treated as a group on that axis. However, it is possible to do some individual alignment in order to separate an item or a group of items from others by using auto margins along with flexbox. A common pattern is a navigation bar where some key items are aligned to the right with the main group on the left. You might think that this should be a use case for a justify self property. However, consider the image below. I have 3 items on one side and 2 on the other. If I were to use justify self on item D, it would also change the alignment of item E that follows, which may or may not be my intention. Okay, A, B, C, and there's a space, and then D and E. Instead, we can target item 4 and separate it from the first 3 items by giving it a margin left value of auto. Auto margins will take up all of the space that they can on their axis. It is how centering a block with margin auto left and right works. Each side tries to take as much space as it can, and so the block is pushed into the middle. In this live example, I have flex items arranged simply into a row with the basic flex values, and the class push has a margin left auto. You can try removing this or adding the class to another item to see how it works. Okay, so we got 1, 2, 3, 4, and 5. Okay, dot box, display flex, dot push, margin left auto. Then we got div class box, div 1, 2, 3, and then we have the div class push 4, and then 5. Future alignment features for Flexbox. At the beginning of this article, I explained the alignment properties currently contained in the Level 1 Flexbox specification are also included in Box Alignment Level 3, which may well extend these properties and values in the future. We have already seen one place where this has happened, with the introduction of the space evenly value for align content and justify content properties. The box alignment module also includes other methods of creating space between items, such as the column gap and row gap features as seen in CSS grid layout. The inclusion of these properties in box alignment means that in future we should be able to use column gap and row gap in Flex layouts too. And in Flexbox and in Firefox 63, you will find the first browser implementation of the gap properties in Flex layout. My suggestion when exploring Flexbox alignment in depth is to do so alongside looking at alignment and grid layout. Both specifications use the alignment properties as detailed in the box alignment specification. You can see how these properties behave when working with a grid in the MDN article Box Alignment in Grid Layout. And I have also compared how alignment works in these specifications in my box alignment cheat sheet. See also box alignment in Flexbox, box alignment in Grid Layout, last modified August 25th, 2020. Then related topics, CSS, CSS reference, CSS Flexbox layout, guides, aligning items in a Flex container, backwards compatibility of Flexbox, basic concepts of Flexbox, controlling ratios of Flex items along the main axis, cross-browser Flexbox mixins, mastering, wrapping of Flex items, ordering Flex items, relationship of Flexbox to other layout methods, typical use cases of Flexbox, properties, Flex, Flex basis, Flex direction, Flex flow, Flex grow, Flex shrink, Flex wrap, and order. And that's all for this article.